This is a web page of a weld controller manufacturer. Expulsion terrible but better than missing welds. You see this sometimes because the user is more comfortable with the outcome of excessive expulsion over the occurrence of missing welds. What this tells me is they have no idea whether they are making a solid-state non-expulsion weld or a missing weld. To play it safe, they choose to weld a terrible expulsion weld instead a non-expulsion good quality weld. Expulsion and its influence on weld quality. Welding schedules can be scientifically selected to effectively prevent expulsion while still obtaining sizable welds. The causes of expulsion are both technical and human-related. In the latter case, expulsion is often used as a visual indicator of a correct welding process. A weld monitor is a device that measures and analyzes welding parameters in real time, helping to ensure weld quality and consistency. It can be used for process development, monitoring, and quality control in various welding applications. Quality control, QC, is a process that ensures products or services meet specific standards and requirements, minimizing defects and maximizing customer satisfaction. A resistance welding monitor is a device that measures and analyzes various parameters during the resistance welding process, such as current, voltage, force, and displacement, to ensure weld quality and identify potential issues. It helps in process development, monitoring, and data collection for quality control. However, all the weld monitors on the market only collect data and do not analyze them to determine the quality of weld. They cannot even tell the difference between a non-expulsion solid-state weld from a missing weld. When I started welding, my company installed a pod weld monitoring system for several $1 million. At first they would collect the data from each weld cell, and at the end of day they would print out all the information and trying to figure out the quality of welds from these data. After a few months they stopped printing out the data altogether. Few more months later they assigned a person to erase the data every week and create more room on the hard drive for next week. I heard after a few years they just take down all the pods from this line. I asked the chief engineer of Livingston Group why don't they analyze the data and just display whether a good weld or a bad weld was made. He told me they cannot make a conclusion of the weld quality from these data. It is up to the customer to decide whether a good weld or bad weld was made. I thought if a weld monitor cannot even tell a good weld from a missing weld, then what good is it?
Hi guys, today we are going to look at the shutter sounds of Canon EOS R. Let's take a photo and hear the shutter sound. Yes, this is the regular mode. Okay, let's jump into the burst mode. Single shooting from high speed continuous shot, which is 8 fps per second.
Even with an electronic shutter, many digital cameras still produce a mechanical shutter sound, because it's often included as a way to mimic the familiar experience of using a traditional camera, and to provide feedback to the user that a photo has been taken. To discourage people to use expulsion as a weld indicator, we must have a weld controller that can tell a non-expulsion weld from a missing weld. Once a weld is detected, a super bright LED panel is lit up for about 1 second to emulate the bright spark from expulsion. This table shows a constant time variable current density experiment. First acceptable weld appears at 9.4 kA or 283 amperes per square millimeter. First expulsion appears at 12.5 kA or 377 amperes per square millimeter. The center of this weld lobe is at 330 amperes per square millimeter. If you weld higher 283 amperes per square millimeter and lower than 377 amperes per square millimeter, you will make a solid-state non-expulsion weld. After plotting this data, the weld lobe looks like this. Since temperature is proportional to current density, we can assume the x-axis is the temperature. Each current density can be represented by a tip wire voltage curve. The peak voltage of a larger current density weld is always higher than the peak voltage of a lower current density weld. By compare the peak voltage of a weld to the peak voltage of the first acceptable weld, we can separate a non-expulsion solid-state weld from a missing weld. The peak voltage of a weld is proportional to the current density of the weld. Any solid-state weld has a higher peak voltage than the peak voltage of the first acceptable weld. If the peak voltage of your weld is higher than the peak voltage of the first acceptable weld, within the first 20 milliseconds you already know you will make a weld. At that point you should turn on a group of white LEDs to emulate the expulsion. If the peak voltage of your weld is lower than the peak voltage of the first acceptable weld, you have made a missing weld, and the LEDs will not turn on. There are three parts to a missing weld detector. The first part is a 4-pole Sallen-Key filter. It is used here to filter out the 1 kHz nit frequency. The cutoff frequency for both stages is 480 Hz. The second part is a voltage comparator. If the peak voltage of your weld is higher than the peak voltage of the first acceptable weld peak voltage, the output of the voltage comparator will trigger in one shot to turn on white LED for about 1 second to emulate the expulsion. If peak voltage is lower than the peak voltage of first acceptable weld, then the LED will stay off. This means you have made a missing weld. The third part is the one-shot. It is used to control the on time of LED. This circuit is another version of missing weld detector. The low-pass filters stay the same. The time delay is implemented with a 555 timer connected as a 1 kHz oscillator and a CD4040 12-bit counter. The third version of the peak detector is an analog peak detector. It stores the peak in a capacitor. This voltage is compared with the peak voltage of the first acceptable weld. The time delay is implemented with CD4106 inverter. The schematics of all three missing weld detectors are provided for you. First, find my video how to program your weld controller to weld expulsion free. Click the blue K under the video. Then click More. You will find all three schematics. There,